Hello, and welcome to Space to Sleep. There is something on Earth that did not come from Earth. It is scattered across deserts, frozen plains, and ordinary backyards, not hidden in deep caves or buried under ancient rock. It is there, in the silent expanses of Arizona, in ice fields stretching for thousands of miles across Antarctica, sometimes in wheat fields of Kansas or farmland in Nebraska. These are fragments that do not belong to this world, pieces of matter that traveled billions of miles through the void before crossing our atmosphere and landing softly, or not so softly, on the ground you walk on every day. Meteorites. That carry within them the memory of a solar system that did not yet exist, of gas clouds that collapsed for and a half billion years ago, of processes that happened before Earth even had form or name. What you may not know is that these rocks are not passing visitors. They do not fall, get studied, and disappear. They stay. Some remain exposed for thousands of years without degrading. Others blend into the soil in such a way that they can only be distinguished with specialized instruments. And there are those, rare, precious, deeply puzzling, that brought with them something beyond minerals and metals. They brought molecules, organic compounds, amino acids, the same fundamental building blocks that, somehow, at some point, gave rise to everything that breathes, grows, and thinks on this planet. The possibility that part of what you came from outside is an idea that remains quiet at the bottom of all this, waiting to be observed calmly. When we think of objects falling from the sky, the image that rises almost automatically is dramatic. Fireballs tearing through the night, smoking craters the size of stadiums, mass extinctions that redefine the history of life. But the everyday reality of extraterrestrial material arriving on Earth is much quieter than that. Every day, approximately 220,000 pounds of cosmic dust crosses our atmosphere. Most of it is so fine that it dissolves in the air before touching the ground. Another portion settles slowly, invisibly, on rooftops, tree leaves, lake surfaces. You have probably touched material from another world without knowing. Perhaps it is now on the sole of your shoe, mixed with the ordinary dust of an ordinary day. There is something profoundly comforting in knowing that Earth is not isolated. That the material composing us did not rise exclusively here, on this small point spinning round an ordinary star. That there is continuity between what happens in distant nebulae and what happens inside your cells at this very moment. This connection is not metaphor. It is not poetry. It is chemistry. It is physics. It is something that can be measured, analyzed, confirmed in laboratories with instruments of extraordinary precision. Scientists in places like the Johnson Space Center in Houston or the laboratories of the Smithsonian Institution spend entire careers examining these fragments with mass spectrometers and electron microscopes. What they find, repeatedly, is a story that began long before Earth existed, mineral grains older than the sun, isotopes that could only have been forged in supernova explosions that illuminated galaxies when our solar system was merely a statistical possibility in a cloud of cold hydrogen. This is not a story of destruction, but of arrival tonight. As you settle in and let your body relax, we will follow together the path of these ancient rocks. We will observe where they come from, how they arrive, what they bring with them, and why some of them, after billions of years wandering in the dark, chose precisely this planet to call home. There is no rush, there is no test at the end, just the possibility of letting your mind float, along with these fragments while sleep approaches slowly. Before we go deeper into this journey, I want to say I am genuinely glad you are here with me tonight. If you are finding this exploration comforting, please consider subscribing to the channel. These nighttime journeys through the quiet corners of science are created especially for moments like this, when you want your mind gently engaged in something real and beautiful, while your body relaxes into rest. And if you ever find yourself struggling with sleepless nights, come back to this. Let it become a familiar companion in those quiet hours when sleep feels distant. That is what it is here for, to guide you softly into rest, whenever you need it. To understand what it means for something ancient to fall from space and stay, you first need to understand just how long that fall really is, not in hours or days, but in scales of time that make human history seem like a single breath. The meteorite that might be sitting right now in a museum display case in Washington, or in a research drawer in a university in Texas, or even in a private collection in someone's home in California, that meteorite has been falling, in a sense, for longer than the Earth has existed. Its journey did not begin when it entered our atmosphere. Its journey began in the cold, dark space between stars, billions of years before our sun ignited. Picture, if you can, the solar system before there was a solar system. About 4.6 billion years ago, there was no sun, no Earth, no planets at all. There was only a vast cloud of gas and dust, mostly hydrogen, but mixed with heavier elements that had been scattered into space by dying stars in earlier generations. This cloud, called a solar nebula, stretched across distances so immense that light itself would take years to cross from one side to the other. And within this cloud, scattered like grains of sand in an endless beach, were the raw materials that would eventually become everything, including you, slowly, over millions of years. Gravity began to pull this cloud together, not all at once, but in patches, in clumps, in regions where the density happened to be slightly higher than average. These denser regions attracted more material, which made them denser still, which attracted even more material. It was a process of patient accumulation, of gradual gathering, of matter finding matter in the dark. At the center of one of these collapsing regions, pressure and temperature rose until hydrogen atoms began to fuse into helium. The sun was born, and round it, in a flattened disk of leftover material, the planets began to form, but not everything became part of a planet. Some of that original material, dust grains, small rocks, chunks of ice and metal, never found a home. They remained in orbit around the young sun, colliding with each other, sometimes sticking together, sometimes breaking apart, but never quite accumulating into anything large enough to call a world. These are the asteroids. These are the comets. These are the leftover building blocks of a solar system that finished its main construction phase billions of years ago, but never quite cleaned up the debris. And some of that debris, through the slow dance of orbital mechanics, through the gentle tugs of Jupiter's gravity, through random collisions that sent fragments spinning off in new directions, eventually found its way to Earth. Not immediately, not directly, but eventually. A rock that formed in the asteroid belt between Mars and Jupiter might orbit the Sun for 3 billion years before a collision with another asteroid sends a piece of it careening inward, toward the inner solar system. That piece might then orbit for another billion years, slowly having its path altered by the gravitational influence of planets it passes, until one day, by pure chance, its orbit intersects with Earth's orbit at the exact moment Earth happens to be there. The fall through our atmosphere is the shortest part of the journey. A few seconds of intense heat as air friction turns the outer surface into a glowing shell of superheated gas. Most small meteoroids burn up completely during this phase, becoming the shooting stars you might see on a clear night, brief streaks of light that mark the end of a billion-year voyage. But the larger ones, the ones with enough mass to survive the fiery passage, slow down as they push through thicker and thicker air. By the time they reach the lower atmosphere, they are no longer glowing. They are falling at terminal velocity, a few hundred miles per hour, which sounds fast but is actually slow enough that many meteorites arrive at the ground barely warm to the touch. And then they land. In a field, in a desert, in someone's backyard. And they wait. They have been waiting for billions of years already. So waiting a few more decades or centuries for someone to pick them up is nothing. They are patient in a way that nothing else on Earth is patient, because they carry within them a sense of time that dwarfs everything we know. The mountains that seem so ancient and permanent to us are newcomers compared to these rocks. The oldest rocks on Earth are about 4 billion years old. Many meteorites are older than that. They predate our planet. They watched, in their silent way, as Earth was still forming. As you breathe slowly and let your body sink deeper into rest, consider that patience. Consider what it means to travel for so long, through so much emptiness, only to arrive here, on this particular planet, at this particular time. There is no purpose to it, no design, just the quiet mathematics of gravity and motion, playing out over timescales that make our lives seem like the flash of a firefly on a summer night. And yet here they are, and here you are. Both of you made of the same ancient stuff, both of you briefly sharing the same planet before your paths diverge again into the long future. The most remarkable thing about meteorites is not that they fell from space. It is what they brought with them when they fell. Because these rocks are not just rocks, they are time capsules. They are samples of the early solar system, preserved in a way that nothing on Earth could ever be preserved, because Earth is alive. Earth has weather and water and tectonic plates that recycle its crust. Earth has life that transforms its surface chemistry. Everything on Earth is constantly being changed, recycled, renewed. But meteorites come from places where nothing has changed for billions of years. They are pristine in a way that seems almost impossible. When scientists carefully cut open a meteorite in a clean laboratory, using tools sterilized to avoid contamination, they find things that should not exist anymore. They find grains of mineral that condensed directly from the gas of the solar nebula before any planets formed. These are called Brazola grains, and they are older than the sun itself. They formed in the outer atmospheres of dying stars, in the expanding shells of red giants. In the violent explosions of supernovae, they were scattered into interstellar space sand, eventually incorporated into the cloud that would become our solar system. And there they remained, trapped inside asteroids, and changed for 4.5 billion years, until a fragment of that asteroid fell to Earth and a scientist with a microscope found them. Think about that for a moment. You can hold in your hand, or rather, a scientist can hold in their carefully gloved hand, a grain of mineral that was created inside a star that died before our sun was born. The atoms in that grain were forged in nuclear fires that burned out long before Earth existed. That grain has traveled through interstellar space, been incorporated into a forming solar system, spent billions of years in an asteroid, survived a violent collision, traveled to Earth, burned through the atmosphere, and landed in a desert where someone happened to find it. And now it sits under a microscope, telling us stories about stars we will never see because they stopped shining before we had eyes to look. But Brazola grains are just the beginning. Meteorites also carry something even more surprising: organic molecules. Not life. We have never found evidence of life in a meteorite, despite occasional sensational claims, but the building blocks of life. Amino acids, the molecules that link together to form proteins. Sugars, the molecules that form the backbone of DNA. Nucleobases, the letters of the genetic code. All of these have been found in certain types of meteorites, particularly a class called carbonaceous chondrites. The most famous of these is the Murchison meteorite, which fell in Australia in 1969, near a small town in Victoria. When scientists analyzed samples of the Murchison meteorite, they found over 90 different amino acids, including many that are used by life on Earth, but also many that are not found in any living organism. This was crucial evidence that these amino acids were not contamination from Earth. They were genuinely extraterrestrial. They had formed in space, through chemical reactions in the cold cloud of gas and dust that preceded our solar system, or perhaps on the surface of the asteroid itself. Through reactions involving water and minerals. The implications of this are profound and also, in a strange way, calming. It means that the chemistry of life is not unique to Earth. It means that the molecules needed for biology are being produced all over the galaxy, in the spaces between stars, in the hearts of asteroids, in places where no one would expect anything interesting to happen. The universe, it turns out, is in the business of making the ingredients for a life, whether there is any life around to use them or not. It is like a kitchen that is always preparing ingredients, even when no one is cooking. This does not mean that life is common in the universe. We still do not know that. The step from having the right molecules to having actual living cells is enormous, and we do not understand how that step happened even on Earth. But it does mean that the raw materials are not rare. It means that if life can rise from those materials, there is no shortage of places where it might happen. And it means that you, lying here tonight, are connected to a cosmic chemistry that stretches back to before the Earth formed and extends outward to every corner of the galaxy. Some of the carbon atoms in your body were once floating in interstellar space. Some of the oxygen you breathe was created in the core of a massive star that exploded before the sun was born. And some of the complex organic molecules that were the precursors to life on Earth may have arrived here on meteorites, falling silently through the atmosphere, carrying with them the potential for everything that would follow. You are not just on Earth. You are of the cosmos. And that connection is not spiritual or metaphorical. It is physical, chemical, traceable in the isotopic signatures of elements and the molecular structures of ancient rocks. Let that thought settle as you relax deeper. You are made of ancient material. The atoms in your body have been through more than you can imagine, through the hearts of stars, through the cold of interstellar space, through the heat of a forming solar system, through the long dark waiting inside an asteroid, through the brief fiery passage into our atmosphere, and finally into the chain of chemistry and biology that led to you. And all of that happened without anyone planning it, without anyone guiding it, just through the patient unfolding of physics and chemistry over timescales that make human concerns seem very small and very temporary. Not all meteorites are found. In fact, most meteorites are never found. They fall into oceans, sink into swamps, disappear into jungles, land on mountaintops where no human will ever climb. The ones we find are a tiny, biased sample, biased toward places where humans happen to look, biased toward places where meteorites stand out against their surroundings, biased toward the kinds of meteorites that survive long enough to be discovered. The best place on Earth to find meteorites is Antarctica. This might seem counterintuitive, a frozen continent where almost no one lives, but there are good reasons for it. First, Antarctica is covered in ice, and ice is white. Meteorites are dark. A black rock sitting on a white ice field is easy to spot, even from far away. Second, Antarctica is a desert. Despite all that ice, very little new snow falls each year, which means meteorites are not quickly buried. They can sit on the surface for thousands of years. Third, the ice flows slowly toward the edges of the continent, and in certain places, it runs up against mountain ranges hidden beneath the surface. When this happens, old ice is pushed up and exposed, and with it, any meteorites that fell long ago and were buried in the ice. These blue ice areas are like conveyor belts, bringing ancient meteorites to the surface where scientists can collect them. Every year, teams from the United States, Japan, and other countries travel to Antarctica specifically to search for meteorites. They ride snowmobiles across the ice fields, scanning the white expanse for dark spots. When they find one, they photograph it, record its location using GPS, and carefully collect it using sterile tools to avoid contamination. Over the decades, these Antarctic searchers have recovered tens of thousands of meteorites, vastly expanding our collection and our understanding of the diversity of material in the solar system. But Antarctica is not the only place meteorites are found. Deserts are also excellent hunting grounds for similar reasons. The Sahara Desert, the deserts of Oman and the Arabian Peninsula, the Atacama Desert in Chile, the deserts of the American Southwest, all of these have yielded significant numbers of meteorites. In deserts, there is little vegetation to hide rocks, little water to cause weathering, and often light-colored sand or soil that makes dark meteorites visible. Nomadic peoples in North Africa have been finding and selling meteorites for decades, creating a commercial market that has its own complex ethics and controversies. And then there are the random falls. The meteorites that land in populated areas and are witnessed coming down. These are rare but precious, because when you see a meteorite fall, you know exactly when and where it landed, which means you can collect it before it has been weathered or contaminated by its environment. Some of the most scientifically valuable meteorites are these observed falls, collected within hours or days of landing. In 1992, a meteorite crashed through the trunk of a Chevrolet Malibu parked in Peekskill, New York. The car's owner, a teenage girl, suddenly found herself in possession of both a damaged car and a rock worth far more than the car had ever been worth. The Peekskill meteorite, as it came to be known, is now displayed in museums and private collections around the world. The car, with its meteorite-damaged trunk, has also become a celebrity, traveling to exhibitions and science centers. In 2007, a meteorite struck near the village of Caracas in Peru, creating a crater about 40 feet wide. Local villagers who approached the crater reported feeling sick, leading to brief fears of some kind of toxic alien contamination. In reality, the sickness was probably caused by arsenic-contaminated groundwater released by the impact, not anything from space. But the incident showed how meteorite falls can still create fear and wonder in equal measure, even in the modern world. Most meteorites, though, fall without anyone noticing. They land in forests and slowly become buried under leaves and soil. They splash into lakes and sink to the bottom. They land in farmers' fields and get plowed under. They land in cities and are mistaken for ordinary rocks, kicked aside, ignored. The Earth is constantly receiving material from space, and almost all of it disappears into the normal processes of a living planet, unnoticed and unstudied. This means that the meteorites we do find are survivors in more ways than one. They survived the journey through space. They survived the passage through the atmosphere. They survived landing on a planet with weather and life and all the forces that destroy and transform. And they survived long enough to be found by one of the few creatures on this planet curious enough to pick up a strange rock and wonder where it came from. Each meteorite in a museum collection represents an almost absurd series of coincidences, a chain of events stretching back billions of years that ended, improbably, with a human hand reaching down and picking it up as you lie here, breathing slowly. You might think about all the meteorites that were never found, all the stories that were never told, all the grains of polymer material and organic molecules that fell to Earth and were lost forever, absorbed into the planet, their secrets dissolved into the noise of a world that was too busy to notice. And you might think about the ones that were found, the ones that ended up under microscopes and in museum cases, and how lucky we are that any of them made it through at all. In a universe of almost infinite loss and dissolution, these small survivors carry messages from the beginning of everything, and we are here to receive them. Some meteorites are more than just samples of the early solar system. Some of them changed the course of life on Earth, not by bringing something, but by bringing destruction on a scale that is difficult to comprehend, and yet strangely peaceful to contemplate from the distance of millions of years. 60-6 million years ago, an asteroid about 6 miles across struck the Earth in what is now the Yucatan Peninsula of Mexico. The impact released energy equivalent to billions of nuclear weapons detonating simultaneously. The immediate effects were catastrophic. A fireball that incinerated everything for hundreds of miles, a shockwave that flattened forests across continents, tsunamis hundreds of feet high that swept across the oceans. But the long-term effects were worse. The impact threw so much dust and debris into the atmosphere that sunlight was blocked for months, perhaps years. Temperatures plummeted, plants died. The animals that depended on plants died. The animals that depended on those animals died. This was the end of the dinosaurs. Not all dinosaurs. Birds survived, and birds are dinosaurs. But the great land dinosaurs, the tyrannosaurs and triceratops and all the rest, vanished in what was, geologically speaking, an instant. An entire world. A world that had existed for over 100 million years, was erased by a rock from space. And yet, from our perspective, that destruction was also a beginning. The extinction of the dinosaurs created ecological space for other creatures to fill. Mammals, which had been small and marginal for the entire age of dinosaurs, suddenly had room to grow, to diversify, to evolve into the incredible variety of forms we see today. Whales and bats and elephants and, eventually, primates. Eventually, us. Without that asteroid impact 66 million years ago, you would not be here. I would not be here. This conversation would not be happening. This is one of the strange truths about the relationship between Earth and the material that falls from space. Sometimes that material is gentle. A rock that lands in a field and waits quietly to be found. And sometimes that material is violent beyond anything we can imagine, reshaping the entire trajectory of life on a planet. Both are part of the same phenomenon. Both are part of the ongoing exchange between Earth and the cosmos. The crater from that dinosaur-killing impact, called the Chicxulub crater, is buried under layers of sediment and the waters of the Gulf of Mexico. You cannot see it from the surface. But scientists have mapped it using gravity measurements and drilling projects. And they have confirmed that it matches what we would expect from an impact of that size. They have also found a thin layer of clay all around the world, in rocks that are exactly 66 million years old, and that clay is enriched in iridium. an element that is rare on Earth's surface but common in asteroids. That layer of iridium is the fingerprint of the impactor, a chemical signature that says, something from space was here. There have been other large impacts in Earth's history, some even larger than Chicxulub. About 2 billion years ago, an asteroid created the Vredefort crater in South Africa, which is the largest confirmed impact structure on Earth. Earlier impacts may have been even larger, but the evidence has been erased by the constant recycling of Earth's surface. We live on a planet that has been bombarded throughout its history, and that bombardment has shaped everything about the world we know, the chemistry of the oceans, the composition of the atmosphere, the evolution of life itself. But here's the thing that makes this peaceful rather than frightening. These large impacts are rare, extremely rare. The Chicxulub impactor was an unusual event, the kind of thing that happens perhaps once every 100 million years or so. The chances of a similar impact happening during human civilization are vanishingly small. We have mapped most of the large asteroids in the solar system, and none of them are on collision courses with Earth in the foreseeable future. The sky is not falling. You can sleep peacefully, and there is something else, something almost comforting about the deep history of impacts. It reminds us that change is built into the nature of things, that stability is always temporary, that the world we know is just one frame in a very long movie, and other frames look very different. The dinosaurs had their world, and it was taken from them by a random rock falling from the sky. We have our world, and it too will change, eventually, one way or another. But that does not make the present moment less precious. If anything, it makes it more so. Every moment of stability, every night of peaceful sleep, is a gift from a universe that does not owe us anything. As you rest here, let the deep time of Earth's history wash over you. Millions of years, hundreds of millions. Billions. On those scales, everything changes. Continents drift, oceans open and close, species rise and disappear, and through it all, material keeps falling from space, sometimes gently, sometimes not, connecting this planet to the larger cosmos, reminding us that we are not separate from the universe but part of it, subject to its rhythms and its accidents, but also participants in its endless creativity. Some meteorites are more than just samples of the early solar system. Some of them changed the course of life on Earth, not by bringing something, but by bringing destruction on a scale that is difficult to comprehend, and yet strangely peaceful to contemplate from the distance of millions of years. 60-6 million years ago, an asteroid about 6 miles across struck the Earth in what is now the Yucatan Peninsula of Mexico. The impact released energy equivalent to billions of nuclear weapons detonating simultaneously. The immediate effects were catastrophic. A fireball that incinerated everything for hundreds of miles, a shockwave that flattened forests across continents, tsunamis hundreds of feet high that swept across the oceans. But the long-term effects were worse. The impact threw so much dust and debris into the atmosphere that sunlight was blocked for months, perhaps years. Temperatures plummeted. Plants died. The animals that depended on plants died. The animals that depended on those animals died. This was the end of the dinosaurs. Not all dinosaurs. Birds survived, and birds are dinosaurs. But the great land dinosaurs, the tyrannosaurs and triceratops and all the rest, vanished in what was, geologically speaking, an instant. An entire world, a world that had existed for over 100 million years, was erased by a rock from space. And yet, from our perspective, that destruction was also a beginning. The extinction of the dinosaurs created ecological space for other creatures to fill. Mammals, which had been small and marginal for the entire age of dinosaurs, suddenly had room to grow, to diversify, to evolve into the incredible variety of forms we see today: whales and bats and elephants and, eventually, primates. Eventually, us. Without that asteroid impact 66 million years ago, you would not be here. I would not be here. This conversation would not be happening. This is one of the strange truths about the relationship between Earth and the material that falls from space. Sometimes that material is gentle, a rock that lands in a field and waits quietly to be found. And sometimes that material is violent beyond anything we can imagine, reshaping the entire trajectory of life on a planet. Both are part of the same phenomenon. Both are part of the ongoing exchange between Earth and the cosmos. The crater from that dinosaur-killing impact, called the Chicxulub crater, is buried under layers of sediment and the waters of the Gulf of Mexico. You cannot see it from the surface. But scientists have mapped it using gravity measurements and drilling projects. And they have confirmed that it matches what we would expect from an impact of that size. They have also found a thin layer of clay all around the world, in rocks that are exactly 66 million years old, and that clay is enriched in iridium, an element that is rare on Earth's surface but common in asteroids. That layer of iridium is the fingerprint of the impactor, a chemical signature that says, something from space was here. There have been other large impacts in Earth's history, some even larger than Chicxulub. About 2 billion years ago, an asteroid created the Vredefort crater in South Africa, which is the largest confirmed impact structure on Earth. Earlier impacts may have been even larger, but the evidence has been erased by the constant recycling of Earth's surface. We live on a planet that has been bombarded throughout its history, and that bombardment has shaped everything about the world we know: the chemistry of the oceans, the composition of the atmosphere, the evolution of life itself. But here's the thing that makes this peaceful rather than frightening. These large impacts are rare, extremely rare. The Chicxulub impactor was an unusual event, the kind of thing that happens perhaps once every 100 million years or so. The chances of a similar impact happening during human civilization are vanishingly small. We have mapped most of the large asteroids in the solar system, and none of them are on collision courses with Earth in the foreseeable future. The sky is not falling. You can sleep peacefully, and there is something else, something almost comforting about the deep history of impacts. It reminds us that change is built into the nature of things, that stability is always temporary, that the world we know is just one frame in a very long movie, and other frames look very different. The dinosaurs had their world, and it was taken from them by a random rock falling from the sky. We have our world, and it too will change, eventually, one way or another. But that does not make the present moment less precious. If anything, it makes it more so. Every moment of stability, every night of peaceful sleep, is a gift from a universe that does not owe us anything. As you rest here, let the deep time of Earth's history wash over you. Millions of years, hundreds of millions. Billions. On those scales, everything changes. Continents drift. Oceans open and close. Species rise and disappear, and through it all, material keeps falling from space, sometimes gently, sometimes not, connecting this planet to the larger cosmos, reminding us that we are not separate from the universe but part of it, subject to its rhythms and its accidents, but also participants in its endless creativity. And so we arrive at this moment, though perhaps arrive is not quite the right word when nothing really arrives and nothing really leaves. You are here, resting, breathing. Your body doing its quiet work of keeping you alive while your mind relaxes into the edges of sleep. And somewhere, right now, more material from space is entering Earth's atmosphere. Most of it will burn up, becoming nothing more than a brief streak of light that no one will see. Some of it will make it to the surface and land in places where no one will ever find it. And a tiny fraction, against all odds, will eventually be picked up by a curious hand, examined by curious eyes, and added to our slowly growing understanding of where we came from and what we are. The meteorites that fell and stayed are still here, scattered across the planet, waiting. Some are in museum collections, carefully preserved and studied. Some are in private hands, treasured as curiosities or investments. Some are lying in deserts and ice fields, not yet discovered, keeping their secrets a little longer. And some, the vast majority, have disappeared into the earth, their identity as extraterrestrial visitors erased by the relentless processes of a living planet. But even those are still here, in a sense. Their atoms are still a part of the system. Their ancient material is still participating in the cycles of rock and water and life. You too are a part of these cycles. The carbon in your cells, the oxygen in your breath, the iron in your blood, all of it came from stars, from the spaces between stars. From the long processes that build the solar system and continue to this day. You are not separate from the meteorites that fell and stayed. You are made of the same stuff. You are cousins, in a way, different forms of the same ancient material, shaped by different circumstances into different configurations, but sharing a common origin in the clouds of gas and dust that gave birth to everything. And now, as sleep approaches, you can let all of this settle into a quiet understanding. The universe has been raining material onto this planet for 4.5 billion years. Some of that material became the continents. Some became the oceans. Some became you. And the rain continues, gently, imperceptibly, every day and every night, connecting us to everything beyond our small world. You can close your eyes knowing that you are part of something ancient and vast, something that began long before you and will continue long after. Something that does not require your attention or your effort to keep going. It simply is, and you are part of it. And that is enough. Sleep well. Rest deeply. And when you wake, the ancient material will still be here, still falling, still staying, still weaving the earth and everything on it into the endless fabric of the cosmos. There is nothing you need to do. There is nowhere you need to be. You are already exactly where you belong. Here, now. Made of stars, resting on a planet that catches the gifts of the universe and holds them gently, just as it holds you. Good night.